Hi everyone, welcome to the next lecture on Fourier series. In this video, we are going to discuss interesting example. Here the question is, find the Fourier series for the periodic function f of x is 0 in the interval minus pi to 0 and it is x square in the interval 0 to pi. Also, we have to show that after getting Fourier series, we have to show that and hence pi square by 12 is 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. Similarly, pi square by 6 is this one. Now see here, it is a pi square by 12. So 12 we can write 6 into 2 and that division 2 if we multiply. So same type of term we get here. But here this right hand side is different. It contains all terms positive. But यहाँ पे कैसे alternate plus minus means इस term का use करके you will not get the second part. So how to find this both the condition we will discuss in this video. But before that, if you are the new on my channel, then must subscribe the channel, click on the bell icon so that you will get a notification of my next video because we are discussing many interesting example on Fourier series and interesting topic questions of mathematics problem. And if you have any doubt in particular question, you can send your doubt in Telegram group. Link of Telegram group is given in the description box. Otherwise, send your doubt in comment section. So we will discuss that particular question in the next coming video. Now see how to solve this question. Here our function is given and the function is divided into two parts. Here it is a minus pi to 0, its value is 0 and 0 to pi it is x square. So here I will write that interval wise our function is defined differently. Minus pi to 0 up to this interval value of function is 0 and 0 to pi it is x square. Now when we have given interval minus a to a, that time we are using the concept of even and odd, because when we use the even and odd, so that time our calculation part will be reduced. When it is a even function, that time you only have to find a naught and an. If our function is odd, then we can find only bn. So here our interval is minus pi to pi. That first condition is there, but it is neither even nor odd function. Why? When that function is divided into two parts, जैसे यहाँ पे दिख रहा है minus pi to 0 के लिए 0 है, 0 to pi के लिए x square है. इस तरह से अगर फंक्शन को दो पार्ट्स में डिवाइड किया है तो उसमें क्या होना चाहिए, अगर यहाँ पे x square है तो here it must be minus x square. If it is x square then here it is minus x square. तो same term यहाँ पे डिफाइन होनी चाहिए with different sign, then there is a chances of even and odd function. But here it is a 0 and it is a x square. तो कहीं पे भी आपको f of x replaced by x minus x, so you will not get f of minus x equals to f of x और f of minus x equals to minus f of x. तो ये कहीं पे भी possible नहीं होगा because यहाँ पे different term है. So this function is neither even nor odd function. अगर ये even odd की कैटेगरी में belong नहीं करता है, that means you have to find all three constant a0, an and bn. So here firstly I will write the general formula for Fourier series, and that formula of Fourier series is, it is a naught by 2 plus summation n varies from 1 to infinity an cos nx, it is a n pi x by l when we are discussing the general form, but here interval is minus pi to pi, then this angle is simply nx plus bn sine nx. Consider this Fourier series is our equation 1. तो जो हमें find out करना है, that Fourier series is nothing but this is the Fourier series for the function f of x. Now how to find the a naught? So here first this three constant you have to find out. So here a naught, formula of finding a naught is 1 upon pi integral, here interval is minus pi to pi, that same integral limit you have to take, it is minus pi to pi f of x dx. Now put the value of function. अब function की value put करना है तो interval wise see है, it is different values, तो आपको integration की limit को भी क्या करना पड़ेगा, break करना होगा. कैसे? यहाँ पे जैसे दिख रहा है उसी तरह से you have to break that integration, that is take minus pi to 0 and 0 to pi. So here 1 upon pi outside as it is minus pi to 0 f of x dx plus 0 to pi f of x dx. And here in this first interval, value of function is 0 and second it is a x square. So when we write here 0, the integration of 0 is 0. So no need to write that 0. So I will write only the second integral. So a naught is 1 upon pi as it is, integration of 0 to pi x square dx. Take the integration of x square. Integration of x square is x cube by 3, limit is 0 to pi. Now put upper limit minus of lower limit. So upper limit is pi, put here. So it is a pi cube divided by 3 and this outside pi is there. Now this 1 pi you can cancel out. So it become a pi square by 3. So hence the first constant a naught answer is pi square by 3. So this is the value of a naught. Similarly, you have to find an. So here the formula of finding an, here an is 1 upon pi integral minus pi to pi. Same integration limit you have to take. It is minus pi to pi. So integral limit is minus pi to pi f of x, and in the Fourier series an into it is a cos. So same here we have to take f of x into cos nx dx. Again here break this interval into two parts. So an is 1 upon pi constant outside. You can take minus pi to 0 f of x cos nx dx plus 0 to pi f of x sin 0 to pi cos nx dx. Put the value of function interval wise. Here this function f of x is 0 and it is a x square. So first integration completely is 0. So I will write in simply second integration. So that means our an is 1 upon pi outside term as it is. Integral 0 to pi, it is x square cos nx dx. Now to solve this integration, we have to use integration by parts formula. But यहाँ पे हम कौन सा formula use करेंगे? Continuous integration formula. Continuation में क्या हो जाता है कि ये जो बार बार integration by parts use करने का process है वो avoid हो जाता है. जैसे इंटीग्रेशन ऑफ u v dx है तो कंटिन्यूअस इंटीग्रेशन बाय पार्ट्स फॉर्मूला क्या कहता है? फर्स्ट टर्म यू हैव टू राइट एज इट इज, दैट मींस you have to write as it is. Take the integration of second term. So integration of second term, alternate plus minus, so this term is plus, next is minus. फर्स्ट टर्म का डेरिवेटिव करते जाना है, so it is a derivative, और सेकेंड टर्म का इंटीग्रेशन. So derivative of u is u1 v2 plus u2 v3 minus u3 v4 and so. So ये फॉर्मूला यूज करने से बार बार इंटीग्रेशन बाय पार्ट्स जो यूज करना पड़ता है वो भी यहाँ पे स्किप होता है और एक स्ट्रेट लाइन में यू विल गेट द आंसर. See here our u is x square and cos is nothing but our v. So first u as it is, so I will write here u as it is, that means x square we write as it is. Integration of cos is sin nx divided by n. Coefficient of x you have to write in division. Alternate plus minus, so minus. Take the derivative of first term, so x square derivative is 2x. Take the integration of second term, so this term is sin nx and integration of sin nx is minus cos nx upon n, and this already there is a n, so it become a n square. So same term का आपको integration निकालना है, तो in this term it is already there is a n, and integration of sin again you will get divide n, so it is a n square. Now again take the derivative of first term, so derivative of first term is 2, alternate plus minus, so here it is minus, so I will take plus, so 2, and integration of this bracket term, so integration of cos is sin, but here already is a minus sign, so minus sin nx upon n, and already n square is there, so total n cube, and if we take the next step, so derivative of 2 is 0, so remaining all terms are 0. So first term derivative 2 is there, so derivative of 2 is 0, so no need to write the next step, that remaining all other are 0. Limit is 0 to pi. Now when we put upper limit minus of lower limit in sine, so we know that in a sine n pi and sine 0 are 0. So both sine n pi and sine of 0 is 0. So when we put upper limit in first term, so sine n pi is 0, sine of 0 is 0. Similarly in the last term, sine of n pi is 0 and sine of 0 is 0. So first and last term are 0 for upper as well as lower limit. That means you only have to put upper limit, lower limit in this middle term. So here in the middle term, an is 1 upon pi outside term as it is. Upper limit is pi, so it is a 2 pi cos of this minus of minus plus, so cos n pi divided by n square. Minus of lower limit, so here put x equals to 0, cos of 0 is 1, but see here also you have to put x equals to 0 because this is a complete middle term. So when we put x equals to 0 in this term, so it becomes a 0. So 0 multiplied by any term is 0. So that's why this for lower limit, this middle term is also 0. So here 0 क्यों हो रहा है? Because of multiplication x is there. Now here simplify this term. So when we solve this term, so this pi get cancelled and cos of n pi is nothing but here cos n pi is minus 1 raised to the power n. So instead of this term, we will write minus 1 raised to the power n. So this pi and this pi get cancelled. So it is a 2 minus 1 raised to the power n. This 2 and this is a minus 1 raised to the power n divided by n square. So hence we get the value of constant a n. Note down this term. We will discuss the next constant bn. So the next constant is bn, and formula of finding bn is 1 upon pi integral minus pi to pi f of x into here bn into the sine content. So here we have to take sine nx dx. Now again put the value of function, and to put the value of function, this integral we have to break in two parts. So 1 upon pi constant as it is, integral minus pi to 0 f of x sine nx dx plus of integral 0 to pi f of x sine nx dx. In the first interval, the function is 0 and second it is a x square. So for first term, it is completely 0. So I will write here integral 0 to pi. In this interval, it is x square sine nx dx. Again use integration by parts continuous formula. So first term as it is. So by integration continuous formula, first term x square as it is. Take the integration of second term. Second term is sine, and integration of sine is minus cos nx upon n. Alternate plus minus. So next term is minus. Take the derivative of first term. So 2x integration of second term. So integration of cos is sine nx upon n, and here is a minus sign. So minus sine nx upon n square. Then next term is plus. Alternate plus minus is there. So plus here derivative of first term. Derivative of 2x is 2 and integration of second term. So integration of sine is minus cos, and here it is already minus. So minus of minus become plus. So that is a cos nx upon n cube, and limit is 0 to 1. If we put upper limit minus of lower limit in this term, so for upper as well as lower limit, this term is 0 because sine of pi n pi is 0 and sine of 0 is also 0. So this term is completely 0 for upper as well as lower limit. And here first and last term contain cos, that means you have to put upper limit, lower limit in this term. So here the bn 1 upon pi constant outside term as it is. Put the upper limit pi. So when we put pi here, so it is a minus pi squared cos n pi upon n. So this minus sign is there, that's why we write minus. X is pi square cos n pi upon n. Minus of lower limit, again if we put x equals to 0 here, so x is 0, that means this term is 0. So first term upper limit is there and lower limit is, for lower limit is 0. Here put upper limit, so 2 cos n pi upon n cube minus of lower limit. Here when we put x equals to 0, cos of 0 is 1. तो यहाँ पे लोअर लिमिट के लिए टर्म 0 नहीं है, बिकॉज यहाँ पे मल्टीप्लीकेशन में x नहीं है, बट cos ऑफ 0 क्या होता है 1. सो इट इज ए 2 अपॉन n क्यूब. सो 2 by n क्यूब. नाउ हियर cos n pi is minus 1 raised to the power n. सो cos n pi का वैल्यू हम पुट करेंगे. सो इट इज ए minus pi square is there, minus 1 raised to the power n upon n, then plus 2 minus 1 raised to the power n upon n cube minus 2 n cube. If we take n cube outside, so it become a pi n cube, and here this is a minus 1 raised to the power n and minus, that means total minus 1 raised to the power n plus 1 pi square, and here we are taking n cube common, but यहाँ पे n cube नहीं है, that means यहाँ पे n square से multiply and divide होगा, so that n square will be there. So n square से multiply and divide, so divide n cube we are taking common, so remaining n square plus 2 minus 1 raised to the power n minus 2. अगर और कोई टर्म यहाँ पे कॉमन निकाल सकते होगे तो you can take common. So here all three constants are known, so we have to put this a0, an, bn in equation 1. The equation 1, that is our Fourier series f of x, is a0 by 2, a0 is here, pi square by 6, already division contain 3, and here we have to divide by 2, so it become a 2 into 3, so it is a pi square by 6. So a0 by 2, so it is pi square by 6, plus summation n varies from 1 to infinity, an is 2 minus 1 raised to the power n by n square, it is cos nx, plus bn, value of bn is 1 upon pi n cube minus 1 raised to the power n plus 1 pi square n square plus 2 minus 1 raised to the power n minus 2 into sine nx. So this is the Fourier series for the function f of x. So given function f of x के लिए जो Fourier series हमें find out करना था, तो this is a Fourier series. So note down this Fourier series. Now we discussed using this Fourier series how to find this first series and second one. So here our Fourier series for the given function is pi square by 6 plus summation of this term. तो हमारे लिए जो क्वेश्चन का फर्स्ट पार्ट था, फाइंड द फोरियर सीरीज. सो फाइंड फोरियर सीरीज फॉर दिस फंक्शन. सो दिस इज द आंसर ऑफ आवर फर्स्ट क्वेश्चन. यूजिंग दिस फोरियर सीरीज वी हैव टू शो दिस टू पार्ट. अब इस सीरीज को ऑब्जर्व करोगे तो देयर इज नो साइन एंड कॉस, ना इसमें साइन कॉस है ना इसमें. सो दैट मीन्स इस साइन और कॉस को अगर आपको हटाना है यहाँ से, तो यू हैव टू पुट पर्टिकुलर वैल्यू ऑफ एक्स. फॉर एग्जाम्पल इफ यू पुट एक्स इक्वल्स टू 0, so sine of 0 is 0, sine of cos of 0 is 1. So sine or cos, so x, if you put the value of x, so you will get a corresponding answer of sine and cos. So मतलब वहाँ से sine cos वहाँ से हटा सकते हैं. And in this question, so either you can put 0, pi, so you will get answer. So in Fourier series, as per the interval, you will get this additional part by putting the value of x either 0, pi, minus pi in this way. Because sine of 0 we know, sine of n pi is known, sine cos of n pi is known. तो जो values known है उसी से तो हम ये sine और cos को हटा सकते हैं. If we take sine pi by 2, let's suppose we take x equals to pi by 2, तो sine of n pi by 2, cos of n pi by 2, इनको हमें known नहीं है. So that's why हम अदर कोई value ना put करते हुए directly we can put either 0, pi, 2 pi, minus pi in this way. So I will try for 0. So here if we put x equals to 0, so corresponding value of function is here x equals to 0. So 0 here the value of function is 0 and this function is continuous at 0. So you don't need to check the here डिरिचलेट कंडीशन. तो डिरिचलेट यूज करने की जरूरत नहीं है क्योंकि ये फंक्शन कंटिन्यूअस है एट पॉइंट 0 के लिए. If we put x equals to 0 in this Fourier series formula, the left hand side is 0 because f of 0 is 0. Right hand side is pi square by 6 plus summation n varies from 1 to infinity to minus 1 raised to the power n by n square. Cos of 0 is 1 and sine of 0 is 0. So multiplication 0, the whole term, second term, this summation is 0. So no need to write, or you can write the 0 first and then skip it. Now here expand this summation and this pi square by 6 shift in the left hand side. So it become a minus pi square by 6 equal to, expand this summation, put the value of n is 1. So for odd number it gives the answer negative because minus 1 raised to the power odd. So it is a minus and minus 1 raised to the power even, it is a plus 1. So here n is 1, so it is minus 2 by 1 square, n is 2, so plus 2 by 2 square, n is 3, so it is minus 2 by 3 square and so. Now here multiply by this 2 we can take common, so I will take minus 2 common, so it is a minus pi square by 6 and here minus 2 if we take common, so it is a 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square. I am taking minus sign also common, that's why here minus term become plus, plus term become minus. And if we continue this process, so it is the next term is 1 upon 4 square and so on. Now in the next step, divide by this minus 2. Here minus 2 is in multiplication, shifting will be divide. This minus minus also get cancelled. So here it is a pi square by 12 because if we shift this 2, so 6 into 2 is 12 equal to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. So hence we get the Fourier proof of our first part. तो यहाँ पे जो first part हमें proof करके दिखा रहा था, that is the answer pi square by 12 equals to this one. Now for the second part, अब first part की हेल्प से second नहीं निकाल सकते because here alternate plus minus is there और यहाँ पे सारी term कैसी है positive है, तो इसकी हेल्प से तो you will not get the answer. So how to find? So for that we have to put the another value of x. जैसे यहाँ पे 0 put करके निकाला था, similarly we have to put the another value of x to get the second part. So here we will put for second part, we will put x equals to pi. So what is the value of function at pi? See here, pi is not belonging to this interval because यहाँ पे strictly less है. So मतलब pi इस interval में belong नहीं कर रहा है. So that means this function is discontinuous at pi. और अगर कहीं पे फंक्शन डिसकंटिन्यूअस है तो वहाँ पे आपको डिरिचलेट कंडीशन यूज करना पड़ता है. जैसे यहाँ पे 0 के लिए आपका फंक्शन कैसा था, कंटिन्यूअस था, तो यू कैन पुट डायरेक्टली f of 0 equals to 0, तो you will get the answer. But here our function is discontinuous, so we have to use the Dirichlet condition, and Dirichlet condition says that f of x is f of x from left hand side plus f of x from right hand side divided by 2. तो यहाँ पे हम पाई के लिए फाइंड आउट कर रहे हैं, तो इंस्टेड ऑफ x यू हैव टू राइट पाई. f of pi is f of pi from left hand side plus f of pi from right hand side divided by 2. So left and right means here pi, this is a pi, when we going toward the pi from right hand side or from left hand side. So left hand side is a x squared, so f of function फ्रॉम लेफ्ट हैंड साइड, सो ये आपका पाई, तो यहाँ पे अगर टुवर्ड द पाई लेफ्ट साइड से जाते हो तो वैल्यू ऑफ फंक्शन इज एक्स स्क्वायर, सो यहाँ पे आएगा एक्स स्क्वायर और एट पाई इट बिकम अ पाई स्क्वायर बाय 2. सो इट बिकम अ पाई स्क्वायर प्लस फ्रॉम राइट हैंड साइड, सो पाई के टुवर्ड जाने के लिए फ्रॉम राइट साइड देयर इज नो पाथ, सो अगर हम पाई राइट साइड से नहीं जा सकते दैट मीन्स देयर इज नो फंक्शन, सो नॉट फंक्शन, सो देयर इज नो एग्जिस्ट So we write as 0 divided by 2. So value of function at pi is pi square by 2. तो function f of pi is pi square by 2. तो इस तरह से आपको डिरिचलेट कंडीशन यूज करना है. I will again explain what is a Dirichlet condition. At pi, here function is not defined, that means it is discontinuous. So we have to find f of pi from left side plus f of pi right hand side divided by 2. तो जो हमारा इंटरवल गिवन है यहाँ पे 0 है, इधर pi. So when we going toward the pi from left hand side, so it is nearest to the pi, but यहाँ पे पोस्ट नहीं है, सिर्फ हम क्या करते हैं, we are going toward the pi. And in this interval, value of function is x square. So f of x अगर यहाँ पे x square है from left hand side, so f of pi become pi square from left hand side. So f of pi from left hand side is pi square. And when we going to from right hand side, so right hand side means very nearest to this function. So यहाँ पे हमारा function periodic function है, तो यहाँ पे next में इस side से जाओगे तो that is the 0, और we can say यहाँ पे नहीं है तो we get the 0. So in this term the value of function is 0. So from right hand side our function is 0. So if we find the value at pi also, so it is a 0. From right hand side it become a 0. So that's why here it is a 0. So pi square plus 0 is pi square by 2. So here the f of pi is pi square by 2 by using Dirichlet condition. So now put this x equals to pi in this formula. So here in this formula left hand side is our pi square by 2. Just हमने अभी find out किया at pi value is pi square by 2. So here pi square by 2 equal to here pi square by 6 plus summation n varies from 1 to infinity. N is we are putting pi, so it is a 2 minus 1 raised to the power n cos n pi divided by n square. X is pi, so it is a cos n pi, and sin n pi is 0. So again this whole second term is 0. So here this is a 0. Now cos of n pi is minus 1 raised to the power n. So ये cos of n pi अगर minus 1 raised to the power n है, so here in the next step it is nothing but pi square by 6 first term as it is, pi square by 6 this first term as it is, plus summation n varies from 1 to infinity. Cos is minus 1 raised to the power n, and this minus 1 raised to the power n, so that is a minus 1 raised to the power 2n upon n square. And 2n, so minus 1 raised to the power 2 is 1, so minus 1 raised to the power 2n is 1. So यहाँ पे by our search formula you can write here 2 into n. So minus 1 raised to the power 2 is 1, and 1 raised to the power n is again 1. So in short this term become a 1. So here this pi square by 2 and this pi square by 6, if we shift in left hand side, so it is a minus pi square by 6 equal to summation n varies from 1 to infinity, it is 2 by n square. This is a 1, so remaining is 2 by n square. Simplify this term, so cross multiply if we apply, so it is a 4 by 12 pi square equal to, here expand this formula, so n summation को अगर expand करते हो, so it is a 2 by 1 square plus 2 by 2 square plus 2 by 3 square and 2 by 4 square plus n. So next step, here we have to take 2 common, and if we take 2 common, so shift this term, so you will get divided by 2, and this 4 ones are 4, 4 threes are 12. So 4 ones are 4, 4 threes are 12, and this 2 if we take common and divide, so it become a 2 into 3 is 6. So left hand side is pi square by 6 equals to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square and so on up to the infinity. So hence we get the second part, that is a pi square by 6 equals to this one. So in this way you can solve the Fourier series question. In the next video we will discuss the next interesting question. If you have a doubt, you can send your doubt in Telegram group, and if you are the new on my channel, then must subscribe the channel, click on the bell icon so that you will get a notification of my next video. Also share this video with your maximum friend so that they will also get the benefit of this video. Thank you for watching.